everyone, here's topic 5.4, example 2 and 3, and this is on page 275 of your volume 2 textbook if you want to follow along on print rather than on the computer. So example 2 in section 5.4 says the weather forecast predicted that the evening temperature could get as low as negative 12.5 degrees Fahrenheit. Between afternoon and evening, the temperature dropped by 7.5 degrees Fahrenheit. And the forecast was still correct. What could the afternoon temperature T have been? So in this, one thing I always look for is, what is my inequality going to be? Is it going to be greater than, less than, greater than or equal to, less than or equal to? And the information we're given is that the temperature could get as low as negative 12.5 degrees. So what that means is negative 12.5 degrees is the lowest it could be, which means that the temperature, that's a decimal, that means that the temperature when it was dropping is still greater than or equal to negative 12.5, because we're saying the temperature, the afternoon temperature that drops 7.5 degrees, we're subtracting 7.5, is still greater than negative 12.5. So T stands for the afternoon temperature. Again, we are subtracting because the temperature dropped 7.5 degrees. So afternoon temperature dropped 7.5 degrees, we're subtracting that. And that's going to be the new evening temperature. But we know that it's still warmer than negative 12.5 degrees, which I don't even know if you can say warmer at that point. So the way we solve this is just like with our equations. T minus 7.5 is on the left side of the inequality right now. We want to know what just T is. So in order to get just T, we have to undo that subtraction. That's the opposite operation. So we're going to add 7.5 to both sides of the inequality. So that leaves us with T is greater than or equal to negative 5. What that means is the afternoon temperature was warmer than negative 5 degrees, or it was negative 5 degrees. So on our number line, that means we have a filled in point at negative 5 because it could be equal to negative 5 degrees, but then it's anything greater than that. And greater than that is going to be everything to the right. And then you can check and make sure that you solved this correctly. So if I wanted to check, I could say, well, on my solution graph, 0 was a possible temperature in the afternoon. So then I can check 0 minus 7.5, because afternoon temperature dropping 7.5 degrees equals 7.5. Sorry, equals negative 7.5. Well, negative 7.5 is still greater than, or equal to, but greater than negative 12.5 degrees. So that means this makes sense. So this is our solution written as an inequality, and then this is the graph of our solution. With that example, you're going to do the try it problem, which is also in your textbook. It's about halfway down on page 275. The speed limit on a road drops down to 15 miles per hour around a curve. Mr. Gerard slows down by 10 miles per hour as he drives around the curve. He never drives above the speed limit. What speed was Mr. Gerard driving before the curve? Graph the solution. So you're going to pause this video in your textbook or on another piece of paper. Try and write the inequality and graph the solution, and then I will post the answers to the try it problems in another video. So try this by yourself, and as soon as you think you got it, click play, and we're going to go to the next problem. Okay, hopefully you did the try it for example 2. Now we're going to talk about example 3, which is just a straightforward solve the inequality and then graph the solution. So it says solve the inequality x minus 1/2 is less than negative 2/3. So this is saying we have some number. If we subtract a half from it, our answer is still going to be less than negative 2/3. So you might think of what possible solutions could be. Let's solve it now. We're going to solve it just like we solve our equations. So I'm going to rewrite this. X minus 1/2 is less than negative 2/3. Okay, so to solve this, the opposite of subtracting 1/2 is to add 1/2. So I'm going to add 1/2 to both sides of my inequality. And I get x is less than, negative 2/3 plus 1/2. Okay, fraction time. Let's do it over here. Negative 2/3 plus 1/2. Well, I need to find a common denominator, which is 6. So negative 2/3 is negative 4/6 plus 1/2 would be 3/6. So I know my denominator is going to have a 6 because when we add fractions, the denominator stays the same. Negative 4 plus 3, if I'm at negative, Kodiak, do you want to do math too? That was my dog in the background. Negative 4 plus 3 means you're starting at negative 4 and you're getting closer to 0. So that ends you at negative 1. Yep, you're right, Kodiak, negative 1/6. So, okay, so x is less than negative 1/6 is a solution. So the way that we graph this is x is only less than negative 1/6. It can't be equal to it. So negative 1/6 on a number line is going to be closer to 0 than negative 1. So I'm going to put it right here. It's hard to do this on my computer screen. You might be able to do it more exact. Oops, okay, right there. So there's negative 1/6, and x is any number less than that. So less than points to the left. So that means negative 5 could work, negative 10 could work, negative 1 billion could work. And we can check. Let's say negative 1 billion. Well, if x is negative 1 billion, negative 1 billion minus 1/2 is negative 1 billion 0.5. That's definitely less than the negative 2/3. So it makes sense that this inequality is pointing to the left. Your practice problem like this is, again, on page 275 at the bottom. Solve the inequality n minus 1 3/4 is less than or equal to negative 5/8. Then graph the solution. So come back and you can check the answers in the next video.